they've all said your work is totally flawed because the Earth, the planets are freely rotating bodies about their center of mass and their axis of rotation. There is no external torque moment. So without an external torque moment, you can't have an unbalanced rotating machine. So I had to prove that the Earth is not, and all the planets are not freely rotating bodies. That's why I looked at all the planets as well to find that all were tilted. So the sun is controlling the Earth's movements, or all the planets. Therefore, modeling is acceptable. So the sun creates this offset center, just after the accretionary stage.
Okay.
So because all the planets have got to behave the same. So, and then of course, the work from Caltech showing that between April and October one way and October and April the other way, the Earth is turning a degree per day so it faces correctly, otherwise we'd have a funny shaped day, night. So in other words, it can only be offset to offset. It must be where the gravitation has got a handle on. So every day 1 degree, so we face correctly. So it has to have an offset. It can't avoid it. The equations are for the first time that you have now been able to, because if I'm allowed to mathematically model it, I can work out the circumferential stresses. And once you calculate the circumferential stresses, they're only about in English money, 10.8 pounds per square inch, which is only a flat tire. But in terms of pressure, if you think about it, it's not a high pressure, but it's enough to break basalt apart, which has got a tensile stress of 0.082 pounds per square inch. In other words, it's got no hope of resisting. So by actually quantifying that, I've now made tectonic movements a mathematically viable calculation, which it wasn't before with just saying currents pull it around. I'm saying you've got forces which are doing that for you. And that's all backed up by the fact you've got then accretionary wedges and it's still moving when you've lost your slab pull. And the only thing that will stop a continent moving is another continent in its way, or another convergent margin. The minute you lose your slab pull, you've got to have a force to push it, and that force will push it.
And when you say the minute you lose your slab pull, you mean when the slab breaks?
Slab breaks away, you've gone. It's no more slab pull when the slab breaks off. You have to restart the subduction cycle, but the continent doesn't stop moving. Well, for a start, you've got a supercontinent which has all the stuff's come together. Is about every 500 million years. Then it breaks up. Well, I've given the calculations of the breakup of the forces of the supercontinent, which is your F equals this times your offset center of mass, and then they all come together again. And then in this process, you only need a small change in your center of mass for the whole cycle to start again with a different, heavier, lighter part. So mine, and I can calculate all the forces or estimate the forces. You can't of movement, and possibly also if you drill down deep, you could do the forces which create the different minerals at different depths may be calculatable or estimatable. And then you change the COM, center of mass, changes a wee bit. Only have to change half a kilometer in 6,400. It's not a lot. Not a lot, 0.015%. And the whole process starts over again. So my cycle is a continuous cycle. I don't rely on things coming together, going apart, coming together, going apart, but sudden changes in convection currents. Mine has a definite, follows the path of, is continuous all the time, subject to the positioning of the center of mass.
And the center of mass is not affected by isostasy.
No, center of mass. I think the center of mass the Earth's core rotates different speeds. The Earth sets up magnetic field. Well, it doesn't take much to sort of upset that little bit. You know, we've got a change in tilt. It tells us there's been a change in the position of the core. You know, it's not static, it's dynamic.
Right. One more question. If all of the rotational forces are uniform and calculatable, how come the plates are going in different directions at different speeds?
That's the model. That is the model, that it'll all go from the heavier side to the lighter side, irrespective of hand of rotation. Because once you swing it around this way or that way, it'll still go to the lighter side. So it's shedding itself. It's the fact it's shedding from the centrally heavier part that way. If it all moved one way, you have it to be a different type of equation. But it's moving. If you look at Pangaea, Africa has been more or less constant, whereas all the others have moved. Australia's 6,000 miles away or something. South America, similar distance away. India's gone off northeast. Antarctic's gone on the bottom. It's all dynamic, but it's irrespective of the hand of rotation. It doesn't matter if it turns this way or that way, the same reaction will occur.